video is for University of St. Thomas, Math 005. This is Lesson 7, Part 2. We're talking about distance and slope. For those who are not in University of St. Thomas, that's the main topics that we're going to be talking about here. We're being asked to find the distance between a couple of points and determine whether or not something is an isosceles triangle. Now, I'm going to remind everybody, an isosceles triangle means that two of the sides, at least, are the same length. Now, you can have an isosceles triangle that has all three sides. That is generally referred to as an equilateral triangle. We don't generally refer to that as isosceles anymore because it's all three sides. But for the moment, I want to go ahead and I'm going to do some of this arithmetic on effectively a scratch paper. But we're asked to verify the points at A, which is at 0, 3, and B, which is at 2, negative 3. And then we have a third point that we're going to check as well, that those vertices of the isosceles triangle, two of those have to be the same length. So we're going to go ahead and figure out our length. I've talked briefly about that in a previous video. And basically what that boils down to is my D is going to equal the square root of x1 minus x2, or you could go x2 minus x1, same difference, and then plus my y1 minus y2, and again we're going to square that. All of that is under the square root. This is effectively our Pythagorean theorem, and we're going to go ahead and I'm going to get that started here to see if we have to determine what our side length is on this one from A to B, and then we'll probably do B and C and see where that takes us. If we need to, we'll go from C to A in order to determine that we've got an isosceles triangle. As soon as I found two that are the same length, I'm going to stop because we've done what we need to do. All right, so in our very first one, I'm going to say, let's go with our x's. I'm going to have 2 minus 0, and I'm going to have that quantity squared, plus I'm going to have negative 3 minus 3 quantity squared, and we're going to go ahead and take the square root of that whole thing. All right, and that's going to give us our distance. So I'm going to put distance for A to B. I'm going to put that little AB on the bottom so I know which one I'm talking about. All right, so I'm going to have a negative 2 squared plus, this is going to give me a negative 6 quantity squared, and then we'll take the square root of that whole thing. So at this point, negative 2 times negative 2 is going to give me a positive 4. Negative 6 times negative 6 is going to get me a positive 36. I'm going to take the square root of that, which means that I'm going to have the square root of 40. Now I'm going to point out the fact that I have a 4 that I can pull out of there. The square root of 4 is going to give me a 2. So I'm going to wind up with a 2 square root 10. I can't do anything with that 10. I've got a 2 and a 5. There's no squares in there that I can deal with. So A to B is my length on that is going to be 2 square root 10. So let's go ahead and take a look at B to C. So that's going to get me 2 and negative 3 is my point. And then we're going to have C. Let me go quick back and take a look at what that is. Our C is negative 4, negative 5. Negative 4, negative 5. All right, I'm going to do exactly the same thing as I just did. So I'm going to have my distance from B to C. Right, and just so you know, you can label things like this. This is just simply saying I'm documenting which distance I'm talking about, and that's almost more for me than anybody else, but it's good to know, be able to pin down which one it was. And especially if you come back to it after you've stepped away for a bit, it's really helpful to be able to know, okay, I was looking at the distance between B and C as opposed to A and B or something else. All right, so for my x's, I'm going to have 2 minus a -4, and that whole quantity is going to be squared, plus my -3 minus -5, and we're going to square that, and then that's all under the square root. All right, so 2 minus a -4, that's going to get me a +6. That quantity is squared. Plus, here I'm going to have -3 plus 5. That's going to give me a 2 squared. And if you take a look here, we had these guys were negatives, but as soon as you square them, they stop being negative, they become positives. This is the same set of numbers. I've got 2 squared and 6 squared. I know already that this is going to wind up giving me an isosceles, but let's finish it out just to see it. All right, so I'm going to have a square root of 36 plus 4, which again is going to get me the square root of 40, which I recognize that we can take that 4 and take the square root of that. That's going to give me a 2 square root 10. And so now I know for a fact that those two sides are the same length, which means I do have an isosceles triangle.